Applications of linear systems. So today we're going to see how linear systems can be applied in real-world scenarios, which usually means word problems. So when you are given a situation or a word problem, here is a list of keywords to help you develop the equations or inequalities for that matter if it was that type of situation. So let's practice writing an equation. Number one, when 6 is added to 4 times a number, the result is 50. Find the number. We're not going to actually find the number, but we're just going to practice writing this equation. So we have 4 times something, and we need 4 times a number. So let's say the number is n. It says 6 is added to 4 times n, so 6 plus 4n. The result is 50. Result is, so that usually means equal. So it could look like this. 6 plus 4n equals 50. Or traditionally, we would put 4n plus 6 equals 50. Let's look at number 3. 6 times the difference of a number and 2 is equal to 14. So 6 times, that implies multiplication. The difference, that means subtraction, of a number and 2. So the difference of a number and 2. So number should come first. So let's say n again. And 2. So the difference of n and 2. And then sometimes you got to work backwards, as I'm doing. Times 6. So this needs to be in parentheses, because we want the difference times 6. We don't just want n times 6 or 2 times 6. We want the difference of n and 2 times 6 is equal to 14. Please try the others on your own. Now we're going to write a system and solve systems. Using the table, write the equations that represent the cost of printing digital photos at each lab. Then solve the system to find out the number of photos necessary for the cost to be the same at both stores. So it says on the online store, it costs 15 cents per photo plus $2.70 for shipping. At the local store, it's 25 cents per photo. So for our first equation, well, we need to establish our variables, sorry. We could say P represents photo, and C represents cost, because those are the unknowns in this situation. We don't know the number of photos and we don't know the total cost at this time. So on the online store, the cost is equal to 0.15 times each photo plus $2.70 for shipping. At the store, the cost is equal to 25 cents per photo. Sorry, something went wrong with my stylus. So these are our two equations for this system. Now to solve the system you could solve it using substitution, you could solve it using matrices, you could solve it using elimination. There's various ways of solving this system. I'm going to use substitution. I'm going to take these two expressions and equal them to each other because they're both equal to c, so that means they should both equal each other. So that means 0.15p plus 2.70 is equal to 0.25p. That's what we're trying to figure out, is when will the cost be the same at both stores? And how many photos will it take for that to be the same? So I would subtract 0.15 from each side. 0.15p, sorry. Oops. Which would leave me with 270 is equal to 0.10p. And then I would divide both sides by 0.10. So let's grab our handy dandy calculator. All right, so 270 divided by 10 is equal to 27. So in other words, it requires 27 photos before the cost is the same, no matter if you get it online or at the store. So 27 is equal to P. So again, it's 27 photos before the cost is the same. If you wanted to figure out what that cost would be, you would just take 27 and substitute it for P into any one of the equations to figure out what the total cost is. But we don't need to do that at this time. The question asks for us just to find out the number of photos necessary for the cost to be the same. So it would be 27. Number 6. At a park, there are 38 people playing tennis. Some are playing doubles, some are playing singles. There are 13 matches in progress. A doubles match requires 4 players, and a singles match requires 2 players. That's probably going to be relevant information. Write and solve a system for this scenario. How many of each match are in progress? So we know there's a total of 38 people playing. We know there's a total of 13 matches. So those totals are probably going to be at the end of our equations somehow, some way. So we're going to need our unknowns. Our unknowns in this situation are singles. So I'm going to use S for single, and doubles. So D for doubles. Because at the end of the day, that's what we're going to want to know. How many single matches are in progress? How many doubles matches are in progress? So we know that there are 13 total matches. So we're going to start with that one. So we know that single plus double is equal to 13. That one's pretty simple and self-explanatory because there's only 2 different types of matches and there's a total of 13. Now here's where it requires a little bit of thought. So we know it requires 2 players per single. So we that when it's 2 per, that's a multiplication implication. So that means 2 times S. And it requires 4 for doubles, so that's a 4 times D. So that'll tell me how many people in total are playing. So that total would be 38. So here's the system of equations that could be used to solve this scenario. I would like for you to finish solving to see how many S's and how many D's are in this situation. A youth group went on a trip to an amusement park, traveling in 2 vans. The number of people in each van and the total cost of admission are shown in the table. Write and solve a system for this scenario. Find the adult price and the student price of admission. So when it's given to us in a table like this, it's pretty simple to develop an equation. So again, we always got to establish our unknowns. So our unknowns in this scenario are adult price. So I'm going to use A for adult. And I'm going to use S for student price. I try and make the variables resemble the scenario instead of always using X and Y because it makes it a little bit more realistic and easy to remember. Okay, what does this mean and what does that mean if they kind of have the same starting letter, if that makes sense. So for van A, it was 2 times A plus 5 times S is equal to $77. That was the total cost. In van B, for our second equation, it was 2 adults plus 7 times S for a total of $95. And so those would be the 2 equations for this scenario. Now we can solve it. For this situation, I would use matrices since it's already both of the equations are written in standard form. All variables are lined up and it's pretty matrices take less than a few seconds to calculate. But before we grab our calculator, let's set up our augmented matrix. Remember, the augmented matrix is all the numbers in your system and none of the variables. Make sure you put them in the same order as they appear on in the equations, and it shouldn't your output should come out in the same order as well. So for my first row of my matrix, it would be 2, 5, 77. In the second row of my matrix, it would be 2, 7, 95. Now let's grab our calculator. Again, to get to the matrix, it's second x to the negative 1. We're about to do some math with our matrix, so we go to math, and then we hit second apps for our, uh, not second app, sorry. Let's rewind. Go back to matrix, so second matrix, math, and it was alpha app, sorry, for RF to appear. In other words, I'm choosing option B. If you were to scroll up and down the list to look for RF, it's option B. And now we need to get our matrix here, so we would hit alpha, zoom. Our matrix has 2 rows, so right now it always starts out on OK, so you have to use the up arrow to get off OK. And make sure the square is around 2 before you hit enter. to change it. Then go to the columns. We have 3 columns. Again, columns go up and down. So we hit enter on 3. Now go back down to OK and hit enter. Now type in our numbers, hitting the right arrow after each one. And now we can hit enter. Once we verify that our data is correct from what we wrote down, hit enter. So the output is 1016 and 019. So you might want to write that down. One, 016, and 019. So again, as long as A always came first and S always came second, that is still the true in your output. A is first and S is second. So what this is saying is A is equal to 16. And what did A represent? Adult price. So that means each adult ticket is $16. And S is equal to 9. And S represented student price. So each student price was $9. So that's how you solve this system. Number 8. The posted results of a recent high school swim meet state that 24 individuals placed, earning a combined total of 53 points. First place earned 3 points, second place earned 2 points, third place earned 1 point. So there's a lot of different numbers in this scenario that are meant to throw you off. Make sure you underline the important details. So far we know we have 24 people. We know that if you're first, you earn 3. If you're second, you get 2 points. And if you're third, you get 1 point, which makes sense. That the last place should get the least amount of points. Then it says there were as many finishers in first place as second and third combined. Okay. Write and solve a system to determine the number of finishers. Oh, I forgot. The total points was 53. That's going to be another important equation. So we need our variables. So let's have F be first. We'll have S be second. And T be third place. Okay? So there was 24 individuals combined. So that means F first place plus second place plus third place should equal 24. Does that make sense? Yes. We know that there was a total combined of 53 points. So 53 is going to be at the end of another equation. But here's where it gets kind of tricky. So each first place person got 3 points. So that means it's 3 times F. Each second was 2 points. So that's 2 times S. And each third place got 1. So you could say 1 times T or just T. But let's put 1 just so you don't forget that there's a 1 in front. It also goes to tell us that there were as many first place as second and third combined. So when you combine something, that's addition. So first place was equal to a combination of second and third. So it would look like that. first place is equal to second and third. So we have three unknowns, so we should have three equations in this system. Anytime you have three unknowns, you should have three equations. Now, to solve this system, we're definitely going to use matrices, but we can't use matrices until all of our variables are on one side and they're all aligned with each other. So my first two equations have F, S, T in that order. When you look at my third equation, it's only F. So we have to move S to the left, we have to move T to the left. And when you do that, you're going to be changing the signs of both of them because you're moving them to the other side of the equation. And when you take S away from S, you get 0. When you take T away from T, you get 0. So there's always something still left on that side. It's just 0. So the new equations would look like this. Well, the first one stays the same. So F plus S plus T equals 24. Second one will stay the same. 3F plus 2S plus T equals 53. But the new third equation is as follows. F minus S minus T equals 0. Again, your equations have to be written in this exact order before you can write your matrix. So our augmented matrix would look like this. So 1, 1, 1, 24 on our top row. 3, 2, 1, 53 on our bottom. 1, negative 1, negative 1, and 0 on our third equation. So as long as your variables are in that order, when you set it up in the matrix, when you see your output, your variable will be in that same order. F first, then S, then T. So remember that when we put it into the calculator. So we need our RF again. So second matrix, math, alpha, apps. And then we need our matrix. So alpha, zoom. Now this time we have 3 rows. And we have 4 columns. Now we hit OK. Okay, enter the data. Oops, I meant to hit the right arrow. See what happens when you don't continually hit the right arrow? Make sure you hit the negative sign, not the minus sign. Otherwise it won't calculate. And now we can hit enter if everything's in there correctly. There we go. Trying to have all those screens at the same time. So here's our output. So again, the order is the same as it was entered as far as variables are concerned. So that means F is equal to 12. So in other words, there was 12 first place finishers. S is equal to 5. So there was 5 second place finishers. And then T is equal to 7. So there were 7 third place finishers. So definitely when we're dealing with applications, don't just tell me 12, 5, 7. Tell me what those numbers mean. So 12 represents first place, 5 represents second place, 7 represents third place. If it's cost, say it's $12, $5, $7. If it's peanuts, 12 peanuts, 5 peanuts. I mean, please be very specific. For these next two, I'm just going to help you set up the equations and you will solve the systems. Nick goes to the amusement park to ride roller coasters, bumper cars, and water slides. The wait for the roller coasters is 1 hour. The water slides, the wait for the bumper cars is 20 minutes, and the wait for the water slides is only 15. Nick rode a total of 10 rides. The number of times he rode the roller coasters was the sum of the times he rode the other two rides. If Nick waited in line a total of 6 hours and 20 minutes, how many of each ride did he go on? So our three unknowns are each represent each ride. So we could have R for roller coasters. We could have B for bumper cars. And W for the water slide. So our first equation should represent the total. That's usually the easiest one. So the total number of rides he rode was 10. So R plus B plus W equals 10. We also know the total of time he waited was 6 hours and 20 minutes. Notice the only ride that lasted an hour was the roller coaster. So, and the other ones were in minutes. So we probably want to convert it all to minutes. We want to probably convert it all to minutes. You have to have the same units. You can't mix and mingle. It just doesn't work that way. So we know that there are 60 minutes in an hour. So he has 6 times 60 minutes because he rode 6 hours. And then plus 20. So 6 times 60 is 360 plus 20. So he rode a total of 380 minutes. Okay. Make sense? All right. With that being said, so for roller coasters, it was 1 hour or 60 minutes. So 60 times R plus 20. See, we don't have to convert this one. It's already ready. 20 times bumper plus 15 times water was equal to a grand total of 380 minutes. It also mentioned that the number of times he rode the roller coasters was, so roller coasters was, so R equals the sum means addition, the times he rode the other two rides. So sum of bumper plus W. So there's our three equations for our three unknowns. Go ahead and solve the system. Definitely use matrices, but remember to set up your equations so that they're in standard form. In other words, all variables on one side. And number 10, I will leave you to work this one out completely on your own because I've already taken up enough of your time. Show me your results. This concludes the lesson.